A projectile can have same range for two angles of projection. T1 and T2 are the time of flights in the two cases. Then what is the product of two time of flights? See, a range will be same na for complementary angles. For complementary angles, range same. So range equal to same. Now complementary angles, if you take in one angle is theta na, one more angle is 90 minus theta. Now range is same na, time T1 you can take. So T1 is nothing but 2u sine theta divided by g. And time period time T2 is nothing but so 2u cos theta divided by c. Why? Because sine 90 minus theta is cos theta. Therefore, if you are product this now, so T1 into T2, then you got 4u square divided by g square times of sine theta cos theta. So sine theta cos theta. From this equation, you can take 2 sine theta cos theta is your sine square theta. You got sine u square theta sine 2 theta divided by g into, so here 2 we need to take in and here g. So therefore, so you got T1 and T2. So T1 and T2 that equal to 2 times of range R divided by G. 2 times of range R divided by G. So hence, so T1, T2 is directly proportional to R. Go with the option 2. Next, second question. A particle projected with a velocity v so that its range on a horizontal plane is twice the greatest height. So range on horizontal plane is twice the greatest height. So maximum height attained. If g is the acceleration due to gravity, then its range in terms of v and g they are expecting. So range is nothing but so u square sine 2 theta divided by g that equal to twice. So twice of maximum height u square sine square theta divided by 2g. Now you can equate this one. U square get cancel, g and g get cancel, 2 sine theta. So you can write this equation 4 times of sine theta cos theta equal to sine square theta. 4 times of sine theta cos theta equal to sine square theta. Sine theta square theta get cancelled. Therefore, you got tan theta equal to 4. Now, you got the range. So, tan theta equal to 4 na, draw a diagram. So, if you take as base, it is a theta for tan, opposite divided by adjacent. Then this value you can take 16 plus 1, 17. Now, range formula you can see. So range is nothing but R. So u square sine square theta divided by 2g. U square sine square theta divided by, then its range is. So u square value, so they are projected with velocity v. Therefore, u square sine square theta. From this equation, sine square is nothing but, so sine value 4 divided by under root 17. See here, we'll equate the problem properly. So these that cancel not sine 2 theta you can write as 2 sine theta cos theta, 2 sine theta cos theta, that must be equal to 2 times of 2 and here 2 and here 2 get cancelled. Therefore, here 2 is not there. So sine square theta will be. Therefore, sine theta square theta get cancelled. From this equation, you got tan theta equal to 2. Now you can draw a triangle. So if you take next base, it is a theta. Tan theta is 2 into 1. So hypotenuse opposite divided by adjacent. Therefore, your hypotenuse value you got under root 5. So therefore, range of a projectile. So u square sine 2 theta divided by 2g. U square sine 2 theta by divided by g. Therefore, u square where u is nothing but v square. So sine of so 2 theta. So sine 2 theta I can write as sine theta cos theta into 2. So 2 divided by g. Therefore, you got 2v square sine theta from the equation. So 2 divided by under root 5 into cos theta. So 1 divided by under root 5 times of g. Therefore, you got, so range is 4 times of v square divided by 5g. So 4v square divided by 5g, your answer 1 be the correct. Next. During a projectile motion, if the maximum height equal to horizontal range. So if the maximum height equal to horizontal range, then angle of projection. Simply you can use the same formula. So u square sine square theta, u square sine square theta divided by 2g, that must equal to range. So u square sine 2 theta divided by g. Therefore u square get cancelled, g and g get cancelled. Sine square theta, you can write this sine 2 theta is 2 sine theta cos theta, 2 sine theta cos theta. So sine square theta and sine theta get cancelled. Therefore, from this equation, tan theta equal to 4 you got. Therefore, theta you can take as tan inverse 4. Next, a body is projected at an angle of 30 degrees with the horizontal. Body is projected at an angle of 30 degrees with the horizontal and with a speed of 30 meter per second. What is the uh, angle with the horizontal after 1.5 seconds? See, here you can take in it is work down, and if a body is projected with velocity 30 meter per second, 30 meter per second makes an angle 30 degrees with the horizon. Makes an angle 30 degrees with the horizon. Then I want the angle with the horizontal. What is the angle with the horizontal after 1.5 seconds? Okay. Here you can see. First we need to resolve the velocity into horizontal component and vertical component. So horizontal component 30 cos 30. So therefore 15 root 2 will root 3 will 15 root 3. And along vertical direction 15 meter per second. So like this, if you are resolved, so your velocity into two mutual perpendicular components. So after 1.5 seconds, so final velocity along x direction. That is, it is just a uniform motion along horizontal direction. So 15 root 3 times of 1.5. So 15 root 3 times of 1.5. So 1.5 is nothing but, so you got 15 times of 1.5. Certain value you got. Similarly, you got Vy. So Vy is nothing but initial direction is 15 minus 10 times of time value is 1.5. So here final velocity along vertical direction is equal to 0. Therefore, only x component will be there. So Vx we need to take in. So therefore, so if your projectile, so if you projected like this now, at maximum height only, vertical component of velocity will become 0. So Vy equal to 0 and Vx does not equal to 0. Vx does not equal to 0. Hence, from this we will conclude it the object is at maximum height. At a maximum height, angle made with the projectile with the horizontal is 0 degrees. Next, a body is projected at an angle of 30 degrees with the horizontal. Next problem. So I think it is a repeated problem. But delete it. Next, at what angle with the horizontal should be a ball be thrown so that the range is related to the time of flight as, see, a range we need to take in 5 times of t square. So we need to find out the angle of incidence. The range formula, so u square sine 2 theta divided by g, and that equal to 5 times of t square. T formula is 2u sine theta divided by g whole square. Then, so you got 5 into 4 u square sine square theta divided by g square. So g value you can take in 10. Therefore, here g and here g value get cancelled. 5 ones are 5 twos are 2 ones are 2 twos are u square and u square get cancelled. Sin 2 theta you can write as 2 sin theta cos theta. So here sin square theta and here sin theta get cancelled. Therefore, you got 2 and 2 is also get cancelled. So therefore, tan theta you got equal to 1. So hence, theta we need to take next to be as a 45 degrees. So therefore, your option 2 will be the correct. Now, a ball is projected from the ground. A ball is projected from the ground at an angle theta with the horizontal. After 1 second, it is moving at an angle 45 degrees with the horizontal. And after 2 seconds, it is moving horizontally. What is the velocity of projection of the ball? Now here and taken it is your ground. And if you have projected one object, like this projectile will be we need to take at 1 second, after 1 second, it makes an angle, velocity makes an angle 45 degrees with the horizontal. But after 2 seconds, it moves horizontal direction. And here 1 second, and here we need to take it as to be as a 2 seconds. See, they are asking velocity of ball. What is the velocity of a ball? Now here you can take an initial velocity is u, and it makes an angle theta with the horizontal. Now u cos theta along horizontal and u sin theta along vertical. So u sin theta along vertical. Now time to reach the maximum height is 2 seconds. That is u sin theta divided by g, that equal to 2 seconds. Therefore, u sin theta component you can take as to be as 20 meters. So u sin theta is 20 meter per second. Now after 1 second, the velocity, horizontal component of velocity equal to vertical component of velocity. Now u sin theta equal to 20 second. Now after 1 second, its velocity if you are treated as to be as a v, therefore v minus u sin theta. Why? Because initial velocity is u sin theta, that equal to minus 10. Why? Because acceleration due to gravity is acting downside. So acceleration due to gravity is acting downside, and initial direction of motion is acting upside. So minus 10. So u sin theta is 20. Therefore, velocity at a time t equal to 1. So you got at minus 10 plus 20. Therefore, you got 10 meter per second. So hence, after 1 second, horizontal component of velocity and vertical component of velocity will be same. Therefore, horizontal component of velocity is 10 meter per second and vertical component of velocity is 20 meter per second. So hence your initial velocity u be equal to under root 20 square plus 10 square. Then you got 10 times of root 5. Then option C be the correct for this question. One more problem. The projectile is projected with initial velocity 6 I cap plus 8 j cap meter per second from the ground. Now here you can write. So let us you can take in it is a horizontal and it is your vertical. So initial velocity you can take in it is u. Along horizontal direction is 6 meter per second and along vertical direction is 8 meter per second. 8 meter per second from the ground. The velocity when it is above to hit the ground is, so already you know that whenever projectile is traveling like this, horizontal component of velocity does not changes, but vertical component of velocity will be reversed. Like this velocity we need to take in, that is 8 meter per second. Hence, resultant velocity we need to take in this direction. Therefore, you got that velocity is 6 I cap minus 8 j cap. 6 I cap minus 8 j cap. Answer 2 be the correct. Now, the angle of projection which is projected with a certain velocity from the ground is pi by 8 with a horizontal. The angle of projection of a projectile which is projected from certain velocity from the ground is pi by 8 with a horizontal. And its horizontal range is capital R. The angle with the horizontal for another projectile have the same range. So already you know that for complementary angles, for complementary angles, for complementary angles range same. For complementary angles range same. So now if you taken pi by 2 is one angle, if you taken one more angle is theta, then definitely this sum will becomes pi by 2. Therefore theta must taken as to be as pi by 2 minus pi by 8. So hence your LCM for this one is 8. Therefore 4 pi minus pi. Therefore you got 3 pi by 8. So hence your answer is 1 with the correct. Now one more question. For angles of projection of projectile at an angle 45 degrees minus theta and 45 degrees plus theta, the horizontal ranges described by the projectiles are in the ratio. Now I want horizontal ranges. So horizontal range equal to u square sine 2 theta divided by g. A simple point of view, I want the ratio and initial velocities are mentioned is a constant. From this equation, you can take r is directly proportional to sine 2 theta. Therefore, r1 divided by r2 that equal to sine of 2 of theta theta 1 divided by sine of 2 of theta 2. Therefore, you got sine of 2 into theta 1 you can take in 45 minus theta divided by sine of 2 of 45 plus theta. So therefore you got this angle is sine of 90 minus 2 theta divided by sine of 90 plus theta. So 90 plus 2 theta. So sine 90 minus theta cos theta. So cos 2 theta divided by sine 90 plus theta. So 90 plus theta is in a second quadrant. Second quadrant sine is positive. Hence you got a cos 2 theta. Therefore both are get cancelled. You got the answer is 1. Similarly, now here you can see next problem. So 1 is to 1 now option 1 be the correct. A projectile is fired at some angle theta with the speed v naught such that it crosses two walls of equal heights symmetrically as shown. The angle of projection with the horizontal. We need to find out the theta. Now here 2 seconds and here 6 seconds. Therefore, total time of flight you can take in 8 seconds. So T1 plus T2 is the total time of flight. And u 2u sine theta. So 2u sine theta divided by g, that is you can take naturally as 8. So 2 1s are, 2 4s are, therefore u sine theta. So we need to take naturally as a 40 meter per second. With this 2u sine theta, body traveling 20 minutes, right? Okay. Now here you can see with u cos theta, a projectile crosses 120 meters within a 4 seconds. Why? Because 6 seconds and 2 seconds. Therefore, u cos theta you can take distance traveled here it is 120 meters along horizontal divided by time taken you can take in 6 minus 2 that is a 4. So 4 ones are 4 30s are. So take this equation u sin theta you can take naturally as equation 1 and this equation you can take naturally as a 2. I want angular projection. Simply you can take equation 1 divided by equation 2. Therefore, tan theta, so you got 4 divided by 3. So 4 divided by 3 na, if you taken it is a theta 4, 3, 5. Therefore, theta value should be 53 degrees. So hence your answer 1 be the correct. Projectile is fired in such a way that its speed at highest point is half its initial speed, horizontal range of projectile. See, they are given if you take in it is your projectile motion having initial velocity u and it makes an angle theta and the projectile is at the maximum height at the highest point is so u divided by 2. So hence u cos theta equal to u divided by 2. So u cos theta equal to u divided by 2. Therefore, theta should be 60 degrees. So angle of projection theta equal to 60 degrees. Horizontal range of projectile you can take a range r equal to so u square sine 2 theta divided by 2g. Therefore, u square sine of 2 into 60 divided by 2g sine 120 value. U square sine 120 divided by 2g. So sine 120 you can take in sine 90 plus 30. Sine 90 plus 30 is nothing but cos 30. Therefore, root 3 by 4 times of u square divided by g. Next problem. A ball is projected at an angle theta from the horizontal with a speed u. After time t, value of vertical component of velocity becomes equal to value of horizontal component of velocity. Then, see, so if you're taken a ball is projected with a certain angle theta, which is less than 40, greater than 45 degrees from the horizontal with a speed u. After certain amount of time t, so if you taken time over here, the value of vertical component of velocity, that is you can take in uh, vertical component. So here you can take in velocity v. So v sine theta, the vertical component of velocity, that must equal to horizontal component of velocity, v cos theta. So v sine theta, that must equal to v cos theta. V cos theta is nothing but u cos theta only. No need to change at all. Now v sine theta equal to u sine theta minus gt. So now you can substitute this equation over here. So u sine theta minus gt, that must equal to u cos theta. So hence, so u if you are common out na, sine theta minus cos theta, that equal to gt. Therefore, time t equal to u by g times of sine theta minus cos theta. One more problem you can see. If a particle is projected with a velocity u so that its horizontal range is thrice the greatest height. So horizontal range is thrice the greatest height. So greatest height. So then its horizontal range is what? So horizontal range is u square sine 2 theta divided by g, that equal to 3 times of u square sine square theta divided by 2g. Therefore, u square get cancelled, and here g and g also get cancelled. Sine 2 theta you can write as, and here sine theta is there. So 2 cos theta, that must equal to 3 by 2 times of sine theta we need to take. Why? Because cancel of sine square and here sine 2 theta, you 2 cos theta will be remains and here sine theta will be remains. Therefore, you got tan theta equal to 4 divided by 3. So 4 divided by 3 na, you can go with the triangle. If you take next specificity theta and it is 4 and it is 3,